Hi everyone, again to IVT, the Intermediate Value Theorem. In this example we have two parts, A and B. In part A you have to show that the equation x cubed plus x squared minus 2x equals to 1 has at least one solution in the interval from -1 to 1. So first you have to construct a function f of x, and here to apply the IVT you have to move 1 to the left hand side to get 0 in the right hand side and to get the function f of x. So we have x cubed plus x squared minus 2x minus 1 equal to 0. So the function f of x is this function. This is f of x, and the interval is given in the question, and it is the interval or the closed interval from -1 to 1. Now, since the function of x is polynomial, this is the first condition. F of x is a polynomial, and this means that it's continuous everywhere. So it will be continuous on the closed interval from -1 to 1. Now you have to check what is the sign of the images of the endpoints under the function f. So f of, this is the second condition of the IVT, so f of -1 equals -1 cubed, then plus -1 squared minus 2 times -1 minus 1. So we have -1 plus 1 plus 2 minus 1, and this gives us 1, and 1 is a positive number, so f of -1 is positive, and you have to find f of 1 and check the sign of f of 1, and we have 1 cubed plus 1 squared minus 2 times 1 minus 1, and this gives us 1 plus 1 2 minus 2 0 minus 1. This equals to -1, which means that f of -1 is negative. So here we have the interval from -1 and 1, and the image of -1 is positive and the image of 1 is negative, which means we have 0 in this interval. So there is at least C in the interval from -1 to 1, the open interval, such that f of C equal 0. So there is a 0, or there is a solution in the open interval from -1 to 1 for the function f of x. Now in part B, show that the equation x to the 4th plus 5x cubed plus 5x minus 1 equals 0 has at least two real solutions in the interval from -6 to 2. So now first you have to check what is f of x. In this example we have already f of x because the right hand side is 0, so this is f of x of our equation, and the interval is given, and the interval is from -6 to 2. So you have to check the conditions of the IVT. Firstly, f of x is a polynomial, which means it is continuous everywhere. So it is continuous on the closed interval from -6 to 2. So the first condition satisfies for the function f. Now secondly, you have to find f of negative 6, and you have to find f of 2. Of negative 6, it is negative 6 to the 4th plus 5 times negative 6 cubed plus 5 times negative 6 minus 1, and this equals to 185, which means that f of negative 6 is positive. Now what about f of 2? It will be 2 to the 4th plus 5 times 2 cubed plus 5 times 2 minus 1, and this gives us 65, and 65 also is a positive number. So the mean value theorem is not working for this interval, because f of negative 6 is positive and f of 2 is positive. We have the same signs for f of a and f of b. So this is negative 6 and this is 2, and the images are positive for the two endpoints, which means we cannot apply the mean or the IVT in the given interval. Now you have to prove that there is two real solutions in this question. So what to do to start the proof? You have to pick a point or pick x inside the interval you have. Let's say pick 0, because 0 it is in the interval from negative 6 to 2. So we split the interval into two sub-intervals, the first one from negative 6 to 0 and the second one from 0 to 2, and you have to check what is f of 0. Now f of 0, you have to plug in 0 here, and you'll get 0 to the 4th plus 5 times 0 cubed plus 5 times 0 minus 1. All these terms are 0 minus 1. This is equals to negative 1, which means that f of 0 is negative. So as you see, f of negative 6 is positive and f of 0 is negative. So there is a 0 here in this interval from negative 6 to 0, and from 0 to 2, 0 has negative image and 2 has positive image, which means IVT applies in this sub-interval. So there is a 0 again in this interval. So really we have at least two real solutions in the entire interval from negative 6 to 2. So there exists C1 and the interval from negative 6 to 0, such that f of C1 equal to 0, and there exists C2 inside the interval from 0 to 2, such that f of C2 equal to 0. And this means we have at least two real solutions in the interval, or in the entire interval from negative 6 to 2. So this is the idea of the question. The interval is not ready in this example, so you have to split the interval into two sub-intervals, and you have to apply the IVT in two intervals, not the entire interval. And that's it. Thank you.